We will use a demo project to show how to visualize sensor information through connection with Amazon Web Services by LTE communications. The target MCU is an RL78 G23. This video guide is in 2 parts. This video is introductory entitled Part 1, Demo Project Overview and Preparations. Please refer to the other video for Part 2, Running the Demo Project. This section gives an overview of the demo project and the development environment. The demo project that comes with the application note is used. This application note can be downloaded from the Renesas website. This video references this application note. Please prepare. The figure shows the system configuration of the demo project. With the initial version of the firmware, the RL78 G23 obtains temperature data from the temperature humidity sensor board, and uploads the data to the AWS IoT core via MQTT communications. Uploaded temperature data can be visualized on the user PC by using Amazon CloudWatch. This demo project can over-the-air update the firmware of the RL78 G23. To update the firmware, upload the image for use in updating from the user PC to Amazon S3. The firmware of the RL78 G23 is updated by OTA updating of the IoT core. The updated firmware operates to upload not only temperature data but also humidity data obtained from the sensor board to the IoT core via MQTT communications. Uploaded temperature and humidity data can be visualized on the user PC by using the CloudWatch system. The list is of the elements of the development environment. This section introduces the hardware configuration and connections. The figure shows the hardware configuration. In this demonstration, we will be using a USB to UART conversion board, MCU board, cellular IoT module, SIM card, and sensor board. Please refer to the application note if you will be using a board modified for use with emulators, an HS300X sensor board, or a SIM card from Nippon SIM. This section introduces how to connect the hardware. Insert the activated SIM card into the back end of the RYZ024A. Connect the antenna and power supply USB cable to the RYZ024A. Connect the RYZ024A to Mod 1 of the MCU board. In the future, the RYZ024A will be replaced by the GM02S from Sequens. Connect the HS400X board to Mod 2 of the MCU board. Connect the USB to UART conversion board to the MCU board. The hardware connections are now complete. This section introduces how to configure AWS for uploading sensor data. Obtain an AWS account, and open the AWS web page. Click on My Account, then AWS Management Console. Open IoT Core. Create a policy. Click on Security, Policies, and then Create Policy. Enter a policy name. Click on Add New Statement 3 times, and then 4 statements will be shown. Under Policy Action, select IoT Connect, IoT Publish, IoT Subscribe, and IoT Receive. Set the entries under Policy Resource as wildcards to allow all resources. Click on Create. After creation is complete, a banner will appear at the top of the screen. Create Things. Click All Devices, Things, and then Create Things. Select Create a Single Thing, and click on Next. Enter a thing name, and click on Next. Select Auto-Generate a New Certificate, and click on Next. Select the policy you have created, and click on Create Thing. Download Device Certificate, Public Key File, and Private Key File. Key files cannot be downloaded after you have proceeded from this screen. Please be sure to download them at this point. After the downloading is completed, click on Done. On completion of creation, another banner will appear at the top of the screen. Under Settings, the AWS IoT endpoint is displayed. This information will be used later, so make a note of it by writing it down. CloudWatch is used in visualizing sensor information. Set up AWS for sensor data visualization. Please refer to the application note for the procedure. Make the AWS settings for OTA updating. Please refer to the application note for the procedure. Use OpenSSL to create signature generation and verification keys for OTA updating. Please refer to the application note for the procedure. This section introduces how to set up the demo project. Set the endpoint and the thing name. Open the header file in an editor. Set the endpoint in the macro definition. Set the name of the created thing as the macro definition in the same file. Set the device certificate and the private key. Open the header file. Set the downloaded device certificate as the macro definition. Set the downloaded private key as the macro definition in the same file. Set the SIM card information. Open the header file. Set the SIM card information in the macro definitions. Set the sensor board information. Open the header file. Set the sensor board information as the macro definition. Create an initial image. Please refer to the application note for the procedure. Create an updated image. Please refer to the application note for the procedure. The next video will show you how to run the demo project. Please continue watching.